Telling the what while pointing to the where. Multimodal queries for image retrieval. In the task of caption-based image retrieval, the goal is to use natural language description to retrieve the most relevant images from a database. Captions allow us to specify the what in the image in a much more fine-grained manner than earlier works which use a class name. Now imagine a user has this top left picture of a horse in the city in mind, so it uses the natural language in A to query the database. The retrieved image, while not the one he had in mind, is a perfect match for this description because the what in the image is similar to the intended target. So the user has to adjust his query to be more specific to point to the where as in B. Expressing the where using the textual query is cumbersome for the user to write and hard for the retrieval system to process. In this work, we propose a new query modality where the user describes the characteristics of the desired target image simultaneously using spoken natural language, the what, and mouse traces over an empty canvas, the where. With this new query modality, we achieve the ideal combo, the fine-grainedness of the what and the ease of pointing to the where, unlike previous work. In practice, to simulate this image retrieval setting, we make use of localized narratives. Here's what its annotation process looks like.
In the front portion of the picture, we can see a dried grass area with the dried twigs. There is a woman standing.
After this, the annotator is asked to type exactly what she has just said. Then using ASR to process the speech and performing text and speech alignment, we can ground the caption words in the image, such as jacket, clouds, or even a relationship like coding. We make use of images, captions, and mouse traces in localized narratives and construct what plus where image retrieval. In particular, given a set of image, caption, and mouse trace that are all synchronized, we form a query image pair by first stripping away the image and keep only the caption and synchronized mouse trace as if it had been drawn on an empty canvas. This forms our input query. Then we place the underlying image in our database as a target for that query. We adapt an image text matching model for the text-only query to operate in this setting. Also taking in the mount trace as part of our query, we modify this model to score instead pairs of text plus trace and image in a database. More specifically, our base models consist of two towers and performs late fusion. On the left, the image tower uses the image region embedder, OIRE, to encode not only semantic, but also 2D location features for each image region. On the right, the text tower uses the text token embedder, or TTE, to encode not only semantic, but also 1D position within word sequence features of each text token. To make this model trace-aware, we turn the mouse traces into a sequence of bounding boxes and inject them into the text tower. The trace box embedding models, or TPE, encodes both the 2D location feature and the 1D text position feature. Hence, it acts as a glue between image regions and text tokens. Our main results indicate that regardless of whether we perform pre-training on open images and or conceptual captions, incorporating the trace leads to significant gains. Overall, the best results is obtained when we both pre-train and inject the trace into our model. In other words, pre-training and our new query modality are complementary. We also perform zero-shot out-of-domain evaluation, taking the two base model and evaluating on COCO and ADE20K axes. We arrive at the same conclusion that the multimodal query with the trace is useful. As an example, notice that the exact positions of the racket and the ball allow the model to retrieve the correct target image. Please check out our paper for more details. Thank you.